how to input your scan files, right? So first you have to input your scan file, because in synchrotron we measure the files in the format of XYE. So you just go, say load scan files, and navigate your folder, then change the files of type as XYE. Then you can see your one, then choose it out. So basically first you have to tell the Topas at what condition you actually measure this data, then only software will know it. So like first we had to tell our emission wave I mean the XRD wavelength. So you just say load, you just right click here and say load emission, or you can directly say load emission file. So synchrotron is only one, right? One wavelength, so you can choose copper alpha 1. If you're using third floor second floor XRD, you choose copper alpha 5. Alpha 5. So you maybe have the question like, because the second floor XRD have only 2 wavelengths, but why is 5? But basically the choppers, okay, they just calibrate alpha 5 for that Bruker D2 phaser. Okay, so no questions, you can simply choose K alpha 5. It won't change much. So you choose K alpha 1, then you just enter what's wavelength you actually measured, 0.82657. Okay, then you have to choose the background, how many background you want to choose it. Like lesser the background, refinement is much better. If you go for higher background, the refinement is more complex. And sometimes you can see like your background, if it's not flat, then you have to use this function 1/x, which is like a polynomial function which used to fit it. So then you have to say the instrument, you don't need to do anything. Maybe very rare cases we have to use this one. But it's not our case. Then you have to say the corrections, like we are using the synchrotron, right? So error will be 0, so you have to say 0 error. If you're using like a second floor XID, so the sample will be displaced. So there you cannot maintain the polarization, so you have to choose sample displacement. And the LP factor is generally called as like a polarization factors. So generally the X-ray source in synchrotron is actually polarized, which means like it is a directional in a particular it is a calibrator for the particular incident angles. But in second floor we don't doing such that. So for LP, for synchrotron is 90, for our in-house is generally 0. Okay. So the missionless is like sometime we have some problem in our XRD, we can use this one. Here you can see like the first XRD peak is actually at somewhat like after 8, right? But also you can see some kind of steep this one. So like this kind of things actually spoil the fitting. So you can choose X will be the 7. At the same time you can see the end tail, it actually falling down. Right, so like even this case also the fitting will be a little bit complex, so you have to choose 48, the minimum one. So just 48. Okay, this is the one. Then you save the file. Okay, you always save the file. So you save the file and just made simple run. Okay, now we can see we actually started the refinement or B. So now we actually set the software what condition we actually measured it. So now we have to give some initial guess to the software, because Redfield is normal the iteration principles. So then you have to choose the zip file. We just select this one. We select your XID file. Then you can choose load zip here, or maybe the right click and choose zip. Okay. Then choose the file. Here it's like a gallium oxide. Okay, you choose the file. Then here you can see like sometimes if you load the zip, you can see no space group. So you have to choose the space group. Maybe I will check it.
C12M1.
Are you sure?
Yes.
12 number, right?
Yes.
Okay, sure. So just choose the file and you just run it. So now you can see before it's 14, right? And now it's like 11. And also we can see something is actually started to fit, which means like we actually choosing somewhat good zip file. So then first, this is the first iteration, right? So whenever you do the refinements, okay, the software equation is adjust to make the fitting very good by changing some of the values here. So first we have to define the lattice parameter, which means like ABC. So maybe the cell may be bigger or larger, so you choose ABC, refine it, and the beta. You see that now it's already changed into 2.61.
Yes, okay.
Okay, then you have to choose the peak type. So here, because this is a normal one, now we have to see like the standard how what type of peaks. So here we have like lot of functions. Basically the FE means like some kind of different, but normally we choose this one like a pseudo wide. This is also pseudo wide, but it's like angular mode principles, but this is like a normal pseudo wide. Pseudo wide means like it will use Lorentz as a Gaussian. So you can see UV is like UVW is like a Lorentz, and XY is like a Gaussian. Sorry, XY is a Gaussian, UV is like a Lorentz, this is a Gaussian. It doesn't matter. You just choose it, and run it. So it will start to run now. So this case is quite good. So now you can see it's already into 1.914. So like you also right click, like you can just do like this, use a mouse keys, and you just move the cursor and you can see how it is actually pitting, where there was any extra picks in our case or not. Okay, then actually first we actually refine this one, right? So then we have to refine the sites. Basically you have to get at least minimum 10 or WP to before going to site refinements, because site refinements, which means like you can see the gallium is at XYG position, right? So like when I choose this XY position will move little bit, and it make refinement little bit good, but it won't move much. Okay, so like when we go for the site, we have to
so RWP less than 2, we go to site, or what?
Maybe RWP less than
10
you can start to refine your site.
Okay,
but don't refine like if you RW like 20 or 25,
that's too much.
don't go for like site, because even though you refine the site, it won't help you much.
Yes.
At the same time, sometimes you have like 20 or 25, will still refine the sites, like some kind of special cases. So first when you go for the sites, you have to look for two things. One, like special positions, whether this system is have the special positions like 0.5, 0.25, 0.75, 1 or 0.33, some kind of trending. So basically those sites should not be refined. It's like a fixed sites. So and also sometimes we also have to look for some kind of relationship. Okay.
Yes.
So like for the starters, we basically say the XYZ should be not negative. Basically it should be from 0 to 1. So here you can see like the Z position is minus, right?
Yes.
So you just put the positive value. How to put like 1 minus 0.2520, like 7.428. You have to enter at the top screen 7948. Similarly we have to change this one, 1 minus 0.31430, 0.6857. Okay, just run it. You can run anytime you want. So here you can see like there was like two screen, right? So which is exactly duplicate, right? So the top one is basically like your primary values. Whatever how to do here. So first before the refinement, we have to set the boundary limits. So boundary limits, like the refinement is just like mathematical calculations. So it will try its best to fit it, so that fitting may be not right. So you always have to set the boundary conditions. So as I say, like generally XYZ will be 0 to 1, right? So the minimum should be 0. So here the Topas is more convenient. You just choose, it's turned into yellow color. You just 1, then you just put 0 and put enter. Everyone will be turned into 0. 0 enter, 0 enter. and similarly OCC and BQ is also 0 to 1, 0. Okay, and set like maximum will be like 1. Okay, and occupancy will be maximum 1. But whenever you do, we should not set BQ maximum value, because BQ is normally like isotropic displacement parameter. It can be many number as higher number as much as possible, but at the same time it should not be 0, which means like that site don't have any atom in it, or maybe it have like vacancy, some kind of principles. So now we have to start the refinement, right? So for that you have to come for the codes. You come for the codes, you choose the atoms. So when you do the refinement, we normally people will advise you to choose from the heavier atom to lighter atom, which means like you have to fix the position of the heavier atom, then move the lighter atom around it. So in this case the heavier atom will be like gallium 1. So I just choose gallium 1. Okay, I can also choose this kind of things. Strategy is basically up to you, and it will change system to system, whether I have to choose only gallium 1 and refine it, or rather had to choose. Basically normally we choose gallium 1 and we refine. After that we fix this one and we choose gallium 2 and we refine it, and later on we will open the both side and refine it. It's actually is up to you, but whatever your case, finally you have to open every side and refine it. So here
why are you not changing refining Y positions?
What the position is like, Y position is like 0. 0 is like some kind of special position in crystallography. You should not do it. 0, 0.25, 0.5, 0.75, 1. Those are like very special position. We should not disturb it.
Okay.
So just run it, and you have to see whether this one is decreasing or not. If it is decreased, is much better. If it's increased, you should not refine it. Similarly, you also have to change this position, whether it is actually moving larger amount or not. You can see like it's decreasing and it's also move little bit. Maybe I just say before it's like 1.9, now it is 1.847, and it turned into some way like very little one. Maybe you can say it's 0.08, right?
Yeah.
Now you can see it's 0.8.
So you're just refining one of those?
Yeah, the position will be refined little bit. Like sometimes if this position suddenly turns into 0, or maybe suddenly turns into 1, or like 0.1 or 0.2, which means that refinement is actually not right, which means that site has some particular issues. So I just say okay, then I choose the lighter atoms, O1, O2, O3. Okay, then I just refine it. Is decreasing.
Yes.
And now I also open this side, gallium. Before that you have to open every atoms and you have to refine it. Okay, it's 0.755. So basically in this case he said x is equal to 0.6.
Yes.
那个是 Kevin 算的，我在算，没有你们我不会错，绝对不会 Kevin 绝对不会错，我知道，我是哪里？没有，我第一次算给他的时候会算错。
Okay. So like he put like aluminum in this case, right? So you have to choose put aluminum at a particular site. So for that you have to choose this. You have to click it. It's turned into yellow, and you have to say add atom at a particular site, and it says aluminum plus 3. Similarly choose here. Then you have to choose here. It will be have aluminum plus 3. Aluminum plus 3. Okay, so here you can just open it and you refine it. OCC, it will refine. Okay, but you can see now here like the gallium one side, it's like 0.25 into 0, right?
0.25 into 0.
And it is 0.650, which is actually not right, because the size should be 1, right? So we basically set some kind of equations, like I just say it's A it is like equal to 1 minus of A, and similarly B 1 minus of B, and I refine. Now you can see it's turned into
Yeah.
1. But again, like in this case of numbers like A is called 1 minus A or 1 minus B, it's not always true. Like sometimes you have to use some kind of special equation
Like 2A.
like 2A something. The people who because I don't know what the composition it is, so I just teaching you, so I just say A 1 minus A, but you have to check with constant for the constraint sometimes. Okay, so like whenever you refine OCC, you always have to refine BEQ. So just open BEQ everything and you just refine it. Now you just see it's turned into minus 207.
Yeah, that's not right.
That is not right. So actually what we actually do is we just refine it like based on the sites. I just say DD
What is DT?
any words you can write it. Even you can write your same name. Okay, but you see, like I write my name in the this both sides, right? Which means like it's some kind of constraint. The value should be same.
Oh.
Okay. So here I just write like okay. Because I say because this everything have like same multiplicity, so in this case I just refine like I just something like this, because the OCC and the BQ is always height related. So when I change the OCC BQ, the OCC value will be changed. So sometime based on our chemical formula, and we always set the BQ something like this, but I think it's so fine.
All should be open, sites and everything.
Yeah.
For BQ.
Of course we have to open it. You can also close and refine it. For normal cases, as a final refinement, you have to open everything and refine it. But maybe like some special cases, like the one you are using lithium, or some cases you cannot open everything at the same time, because lithium XRD is not sensitive to lithium. So in that case you no need to do like this. So like this kind of strategy, like whether I have to fix or open, I have to open everything, I have to fix something, it depends upon the crystal system, it depends upon your compound. It will change, you have to decide it. So in this case I set like this, and now it will say parameter we is defined it one value, right? Which means like the initial is different value. I just said like 1. Okay, now I refine it. Now it still is 0. Oh, I just say this. Okay. Maximum. Okay, now I just refine it again. Okay, something like this. Okay. Actually, like this case, like somewhat quite different. Okay, because you see, like it's almost close to 0. So I won't say this BQ is very good value. I have to change sometimes, but it's fine. This refinement is finished. Okay. So now I actually finished the refinement, right?
Yeah.
And you can zoom it and you can see it's fitting very good.
Yeah.
You can see here, right?
Yeah.
It's actually fitting very nice.
Yeah.
So like once I finish the refinement, now I want to know whether my fitting is reasonable or reliable or not. So first I have to see some values. Generally you can see this one or here. Okay, so like here we have to see like RWP and RP, which is very important parameter. Okay, RWP and RP. If you're working like cubic systems, the cubic the symmetry is actually quite higher. So in that case the RWP and RP should be less than 10, minimum 10. We should not max higher than 10. But if you use other system like a triclinic or monoclinic, some cases the RWP can be higher than, can be lesser than 15. Okay, less than 15 is still acceptable. But for cubic it should be less than 10. And more normally we will say like how much RWP value is less, which means the fitting is more good. And another parameter you can check is like GOF. The GOF should be like 2 to 3 is very good. Okay,
2 to 3 is good.
yeah.
Okay.
But in this case it's like 0.75 because this is over refinement.
Yeah.
Okay, normally it's not good.
Oh.
We normally recommend it, but GOF is not like a very good parameter to check it out. Maybe if I don't know whether my OCC value is right or wrong. If I check the OCC, then I can have the idea whether it's right or wrong. That's why you have to check your refinements. Okay, now we finish the refinement. I feel the refinement is actually good. Okay, and I also forgot to tell one thing, like here you have to click fitting function, right? Here you have to say calculate error. Is very important, and you just click and you just run it. Now everything will be calculated error. Here you can see the error. You can see the parenthesis, right? It represents error, which means like the parenthesis 1.8, right? So this 1.8 is significant to the last 2 digits. Okay, let's say like the point it may be like this 0.511 plus or minus 0.016.
So
You have to read like this.
Okay, it's standard deviation.
Standard deviation, yeah. So it may be like 0.527 or maybe 0.4974, that somewhat like this. Okay,
Now I understand that value.
okay, then error is very important. So now we have to know how to export our data and plot it.
Yeah.
So for that we have to do two things. You just go right click and you just say save y, observe y, calculator y difference. Okay, you just save the file. Okay, this one, then you have to save this file or be text. So this one will contain all your fitting results.
Okay.
In future if you have any issues, you can refer this file. Okay, we just right click and you just say save to text file and you just save it. And then maybe this is how you have to plot it, right? So now you can see like we actually get these two things, the red one, the black one, and also we get the blue one. Okay, but this the Brock's reflection is basically actually it is in the structure. So you have to go into the structure and you have to say like HKLs. Okay, then you have to save like maybe you can choose this one, Control C, and open any Excel, put it there and save it, put it there, copy all selection, paste it, and you save your files. Okay, this is finished for your drawing. Okay, but we have to use some like a drawing structure, right? So for that you have to come into STR output. Here STR output, you can choose these three things.
Don't put it in front of.
So here you can have like generative structure for output for structure. Okay, so you can tick here. Even if you want to calculate the bond length with errors, you can tick here. Anything is fine. Okay. Then you have to say run.
Okay.
It will be run. Okay. Now you can see this is empty, right? Now you can see it is filled with one.
Yes.
So you can right click and you can save into text whatever you want, and similarly go to the stiff structure and right click it and save into the text. You can see like this is like save as like a text, right? But this is a zip file. So we have to tell the software it is a zip. So while you saving, you have to file name dot .sif zip. Then it will be saved as a zip file. Okay, that's it. Refinement finish. And blot your curve.
Okay.
Very good.
Okay.
Thank you.
Then you have to draw the Vesta, right?
Yeah.
You just open the Vesta and go for here and open it. Okay, open your zip file, you download it. Maybe okay. Then it will become like this. Okay. Then what? Then you can use Vesta to draw. You can see like here like style. You have like polyhedral. You can draw your polyhedral, and you can visualize in this one. The polyhedral is much fine. And even if you want to know the volume or like some kind of bond length, you can choose any polyhedral you want. Maybe you click it. Once you click it, then at the bottom you can have all your values, like your bond length, your polyhedral, average bond length, all the things you can get it. Okay. And here you can say the objects. So in the objects you can have like 3-1 atoms, bond and polyhedrals. So in the atoms you can change the colors whatever you want, orange, anything you want. Okay. And even you can change these things also, like this one, adjust whatever you want. And similarly go for the polyhedral, you can also choose the color of the polyhedral, and even you can change your polyhedral appearance, transparency. Okay. And here you can have like one thing like properties. Here the properties you can choose whether you want to show your unique crystals or not, and whether even you can also decide what type of polyhedral you want. This type of polyhedral, anything you want, you can choose it. And sometimes the boundaries like somewhat higher structures, maybe I can manipulate the structure into multiple unit cell by setting the limits. Okay, so I can choose whatever I want. And that's it, it's finished. Okay, so when you want to export, you go to the file and you just say export raster image, and you just like save like a TIFF, and you just like save, and now it will give like ask you like scale values. So like you can choose whatever scale you want. Like if you choose higher scale like 5 or 6, it will take some time, and the file size will be much more bigger, and the image quality will be much more good. So if you choose 1, it will export very short time, and the image may be not so good, and the size will be less. That's it. Okay.
Yeah, finish. Thanks.
Finish.
Thank you.
Thank you so
Okay,
much.
bye bye.
Very nice.